Hi everyone, in this video we're going to talk about objects. Java is a sort of object-oriented programming language. An object represents an entity which can be distinctly identified. In other words, it's a thing. So nouns are a good way to think about objects. So you could have students, classrooms, buttons. Those are all objects. Objects can also be considered custom data types where we define what they mean. So object-oriented programming allows you to break the problem up based on things that are part of the problem. So I use the word things, I use the word nouns. You just think about like what nouns are part of your program, and then you can break the problem up using those nouns. Now, when you have a noun or an object, it has a thing that it is, and then it has a thing that it does. Okay, and what I want you to take away is this is just a sort of general way to think about doing a particular program when you have a problem, right? You do not have to use Java all the time to be able to solve a programming problem, because there are other programming languages out there. And other programming languages have different kinds of strategies for software development, including like functional, procedural, event-driven, and so on. For example, if you do like object-oriented class-based languages, obviously Java is there. This is just on Wikipedia. And you also have Python, right? So other popular languages include C++. So here, these are programming languages that have a particular strategy in the way that you solve the problem. But there's, as you can see on the left-hand side, there are other ways to do it. In fact, some things live in more than one category. You'll notice Python lives in iterative languages as well, along with C++. Other types that I mentioned were functional languages. So here you have things like Haskell. And at the lowest level, we have assembly languages, which are things that correspond directly to machine language. So it's just up to you. It depends on what particular problem you're trying to solve and what is the best tool for it at the time. And then, of course, a lot of programs you can write in different languages, and they'll have different strategies for how to go about doing them. Now, objects go along with classes. Classes are going to define the data and methods to work on that data. So in other words, you're going to define the noun, and then you're going to define what that noun is, like what are its properties, and then what it does. We've used class before because you know that we've used this keyword, at least when we start up a new Java program, we've always written something like public class hello, something like that. So hello is actually can be used as an object. We were just writing maybe a hello world program. It didn't really make sense to instantiate objects of hello world, but there are other kinds where it does make sense to do that. That's what the purpose of this particular lesson is, to think about what kinds of classes and objects make sense for us to use. So more specifically, a class is a template that defines what an object's data fields and methods will be. In other words, what it is, what are its properties, and what its methods are, so what it does. You can create many instances of a class, and creating an instance of a class is known as an instantiation. So we'll talk more about what that means in a second. I think the idea so far of classes and even objects is still a bit abstract, so I'm just going to go through the definition just to say it again in another way. The identity of an object is defined by the variable name assigned to it. The state of an object, which are its properties or attributes, is represented by data fields with their current values. The behavior of an object is defined by methods. So I've just given you a couple of different ways to talk about classes, just different words to use. And hopefully this becomes more clear as we start to actually see examples. Now, when we want to access an object's state or behaviors, you can use the dot operator via the object's reference variable. We've done this before. So we've done, for example, scanner input is equal to new scanner system.in. And then we have said things like input.nextInt. This dot right there between input and nextInt, that's what's called the dot operator. So what you'll understand here actually is that scanner is an object. Okay, input is an instance of scanner. And because input is an instance of scanner, it can use the method nextInt, because nextInt is a method that is associated to the scanner class. All right, so hopefully this is becoming a little bit clearer with each example, so I'll give you some more. We have also talked previously about the random class. Now, the random class allows for getting different kinds of random values, and it uses a seed value to do it. You can declare a new random object using just new random, and in this case, there's nothing that goes in the parentheses. If you want to get a random number between 0 and 25, you can do r.nextInt and then 25. Another thing that you can do is you can get a random Boolean. So r.nextBoolean will give you that. And you can do r.nextDouble to get a random double. So basically, we have the random class. With the random class, you can create random objects. So in this case, that object is r. And now you can use r in different ways to get different kinds of random values. So with the Java classes provided, like random, you can look up in the Java docs what happens in those classes, and you can look at what the properties and what the methods are. So to look up class random, you can see that this class is used to generate a stream of pseudo-random numbers. And one thing that's important is that if two instances of random are created with the same seed and the same sequence of method calls is made for each, they will generate and return identical sequences of numbers. So there are down here, as you keep scrolling on the Java description, you can see what the constructors are for random class. So you see that there are two ways to create a new random object. Either you can do just random with just parentheses, or you can do random with a long in here, and you can put a number in there. And if you keep going, you can see the more details about the constructors and more details about the methods. And in general, for anything that's available in Java, you can always see these descriptions of the constructor and method. One example of where random seeds might be used is if you were playing a game and you wanted to generate the world, you can actually use a seed to do that, and you would leave it blank for a random seed. Now, that way, every time the world is generated, it's going to use that same randomness. here is an example of some code that will create a new random object using a long. And so here, now when we've created a new random object, I have the long 54321 in here, and I can still call out the sequence and get a bunch of random numbers. And the numbers that I'm going to get are 3, 1, 17, and 2. You should try to write this code on your own and see what sequence of numbers you get. Now, in a previous video, we talked about writing a tax return where we hadn't talked about objects yet. And at first, we just wrote all of the logic for the tax return inside the main method. As we learned about methods, we actually were able to peel out the information, and we created a single method called getTax, which took in an income and a status and basically calculated the amount of tax that that person would owe. But notice here I said that person, and yet the way that we've written this main, we never actually created a person. So to practice objects, one thing we can do is we can create what's called driver code. Okay, so that's step one, is to actually peel out this main and put it in a different file called tax return driver. So basically the change here that I'm going to make is right here, where rather than having a main inside a tax return, I'm just going to create an object called a tax return object. And when I declare that tax return object, I'm actually going to put it in with an income and a status. So this sets the fields for a particular tax return object. And now, because I've set these fields, I'm actually going to change the getTax method. If I have an object called tax return that already has an income and status associated with it, guess what? I don't need to declare it as part of the method. So then, going into the driver code, which is just a copy of the main, now what I can do is right here, I can create a new tax return object. And let's say there's a person named Olivia for whom we want to calculate the tax return. Okay, so I'll say tax return, name my object, new tax return, and I still kept all the scanner stuff. So here I can actually say what her income and status is. Okay, so now I've declared a tax return for someone named Olivia, for whom her income is whatever you inputted and her status is whatever you inputted. Now you can actually just calculate how much tax she owes. And now to obtain that value, you're going to do Olivia's return .getTax using dot notation. And since I already know the income and status, because those were the fields in the constructor, I don't need to have those values there anymore. I also changed the parameters of the method to do that. So if you were following along previously, we've already talked about this tax return code. It's possible to basically peel out the tax return logic into a method, right, called getTax, and to create a tax return object that takes in an income and a status. And at that point, it is possible to, inside your driver code, which is just the main, calculate a particular person's tax return. So just to leave you off with some things to practice to be able to understand objects a little bit better and how they interact with Java, try writing out the tax return code that using the example given, and try to instantiate some objects of tax return. I showed you one way to do it, but you can just instantiate some more people if you like. Another thing to do is add another method to the taxReturn.java file and make that be a print tax return method. And rather than having the print in the main method, just call this print tax return in the main. And so we'll call this main print tax return. And think about what the type of that method or the return type of that method will be. And then, of course, finally, just try out running main a couple of different times with different values and see what happens. So this will be really good practice to understand, kind of all the things that we've been talking about so far. We can put it all together. And yeah, that is all I have for you. So thank you for watching.